Alright, so here's your final exam prep packet. Questions that you can expect on your final exam. So again, try to be nice so that this is for you, right? Not for me. So let's look at some odd number questions. Go through it together. If I do all the questions for you, then you're not really preparing. But I need to do some with you. For each function below, what are we going to do? Find the zero in multiplicity. Find the Y-intercept, the power term, and can you state the end behavior? Away we go. Number one, what's the first thing I notice? This is a polynomial. All exponents are positive whole numbers. Next, what I notice is it's factored. Does that help me? Well, I hope so. So for zeros in multiplicity, each factor is going to have a zero to look at. So the first factor is negative 4x to the fifth. What zero comes from that factor? And the answer is 0. And what is the exponent? Odd or even? And so we can either say the multiplicity is 5 or is odd. Do you know when it's an odd multiplicity, it means it's going to cross at 0? How about the second factor? What 0 comes from there? Positive 8. And what multiplicity is it? Next, how do I find the Y-intercept? So if I plug in 0, so that means wherever there's an x, plug in 0, and then solve it. In this case, 0 to the 5 is 0. Negative 4 times 0 is 0. And 0 times whatever that number is 0. So what is the Y-intercept? 0. The power term. This might be the trickiest one. If it's in factored form, you have to multiply it out to find the power term. So what's the term in front? Negative 4x to the fifth. If I multiply it, what's going to be the power term here? It's going to be negative 4x, and you're going to have to add the exponents. So it's negative 4x to the 8. So we need to do some exponent laws. What does that then tell me about the end behavior? As x approaches infinity, where's the right end going? Do you notice it's an even exponent and it's negative? So the right end is going down. Where's the left end going? Also down. So, even doing one question together, is it starting to feel better? All right, number 3. In number 3, I want you to do the same thing. What's different about question number 3? It's still a polynomial, but what's different about it? Is it factored? No. So can you factor it? Yes. So we're going to factor by grouping. Look at the first two terms. What do they have in common? X squared. And when you factor out an x squared, what's left? X plus 3. Look at the last two terms. What do they have in common? Negative 4. And when you divide, what are you left with? X plus 3. So one factor is x plus 3, and the other factor is x squared minus 4. Can x squared subtract 4 be factored further? That's called the difference of squares. So that would be x plus 2 and x. One's plus 2 and the other is subtracting 2. Did we factor it completely? So now we're going to do the same work. What are the zeros? So look at the first factor. What 0 comes from the first factor? Negative 3. It has a multiplicity of what number? 1. We also have positive and negative 2. Both of them have a multiplicity of 1. The Y-intercept. How do I find the y-intercept? Is I plug in 0. I'm not going to go to the factored form. Go back to the expanded form. When you plug in 0 for x, what number's left over? The power term. I'm not going to the factored form. The expanded form, what term has the biggest exponent? X cubed. The end behavior. As x approaches infinity, what does the function approach? Infinity. As x approaches negative infinity, what does the function approach? So that means the right end goes up and the left end goes down. Next, look at number 5 when you're ready. In number 5, we have to do a few things. So first it says determine the end behavior. Find the power function that resembles large values of the absolute value of x, which just means find the power term. So can you find the power term in end behavior? So let's start there. So for number 5, can you tell me the power term? Do you have to be careful because it's factored, yes? So what do I have to do if it's factored is I have to multiply it out. So what term has the biggest exponent there? What would you write down? X cubed. What would you tell me the end behavior is then? So as x approaches infinity, f at x approaches infinity. As x approaches negative infinity, what does f at x approach? So the right end goes up and the left end goes down. Next, can you tell me the x-intercepts? So part B, find the x and y-intercepts. Where's the x-intercepts here? Each factor has an intercept. That's another word for 0, right? So x squared means there's an x-intercept where? At what number? And it has a multiplicity of 2. What's the other 0, or x-intercept? Negative 2, and it has a multiplicity of 1. The y-intercept. If you plug in 0 for x, what answer do you get at the end? 0. D. Can you use a table of values to estimate turning points and sketch a graph? So I can go in either order there. So I'm going to sketch a graph to begin with. So if I want to sketch this polynomial, obviously a good place to start are the x-intercepts, which are 0 and negative 2. What else do I know about this graph? Is the right end goes up and the left end goes down. What would be the obvious x value that I need to plug in to find a turning point? Negative 1. And that's it, right? There's no other integers there. So I'm going to plug in negative 1. That's negative 1 squared and negative 1 plus 2. So negative 1 squared and negative 1 plus 2. That's 1 times 1, which is 1. So where is a good estimate for a turning point? Is at negative 1 and 1. And then you can connect and finish the sketch. Can you tell me where this function is increasing? From negative infinity to negative 1. Where else is it increasing? From 0 to infinity. Where is it decreasing? And we only use the x values. It's decreasing from negative 1 to 0. If I ask you for the maximum, this point here is called a maximum. Yes, a local maximum, which is at negative 1, 1. There is no local minimum. There's only one turning point, and it's a high point in its area. All right, when you're ready, turn the page. Number 7. Number 7. Can you tell me the power term, the end behavior? Can you tell me the intercepts? Can you sketch the polynomial? Use a little table of values if you need to find a turning point. I understand that you're not yet in the mode of school yet. It's tough to get the energy back up again. So the good news is there's no quizzes this week, there's no exams this week, right? We can start slow and then build up momentum, right? Get our energy back up again. You know the most important weeks to a semester are the last 2 weeks, right? To see it go up or see it go down. This is the time to actually put the most effort in, not the other way around. Is it okay if I give you a moment, or do you want me to get right into the question? Now, obviously on the video, you could just fast forward until I start, if that's what you need to do. Don't forget the negative 2 for the power term. So it's negative 2x to the 4th. That means even, and negative in front means both ends go down. What are the zeros of this function? Negative 2 is a constant. There's no number that makes that. That factor has no zero. It needs a variable. The next is x subtract 3. So the 0 is positive 3, and it has a multiplicity of 1. The second factor, the 0 is negative 1, and it has a multiplicity of 3. To find the y-intercept, we plug in 0. This answer will not be 0. It's negative 2. Plug in 0 and you get negative 3. Plug in 0 and you get positive 1. So those are the numbers you're multiplying together. Be careful, and you get positive 6. All right, we're now ready to do a sketch. I know that both ends go down. There are two x coordinates I'm going to use. You know what the two x coordinates are going to use to estimate turning point? Is positive 1 and positive 2. So if I plug in positive 1, it's negative 2, 1 take away 3, 1 plus 1, So if I simplify that, that's negative 2, and 2 to the 3. That's 8 times 4, which is 32. It's okay whatever the number is, because I can make my own scale. And then the other number is 2. I want to know whether 2 gives me a bigger number or a smaller number than 32. So we have negative 2, negative 1, and then 3 cubed. So that's 2 times 27, which is... So which one is my turning point? At positive 1 or positive 2? So at positive 2, what number does it go up to? So I'm going to control my scale. So at positive 2, I'm going to say that is 54. And then 32 can be below it. And then, of course, 6 is way down here somewhere, right, with that scale. And there's a sketch of that polynomial. If I ask you where is it increasing, it's increasing from negative infinity to what x value? 2. And where is it decreasing? From 2 to infinity. And again, there's only a maximum here. There's no local minimums. Try number 9, and then we'll move on to the next unit. Or number 9, and we'll work on the next topic, not the next unit. It's been a while, right? That's why we have today, and tomorrow, and Wednesday, and Thursday, and Friday.
9.
Yes, number 9. Same thing. Can we analyze and graph it? And you know, I will scan the answer key. It'll be up for you. Did you add the exponents going across and get negative x to the 4th? That negative is important because it affects my end behavior. That means both ends are going in what direction? Both ends are going down. Each factor has a 0. Negative x squared. What number makes it 0? And it has a multiplicity of 2. The next factor, the 0 is positive 1, and it has a multiplicity of 1. And the last factor, the 0 is negative 3, and it has a multiplicity again of 1. If it has an even multiplicity, it touches. If it has an odd, it crosses over. To find the y-intercept, what number do I plug into x to find it? And in this case, when I plug in 0, negative 0 squared is 0, and 0 times any numbers that follow is going to be 0. Let's do a sketch. So we have 0, 1, and negative 3. I know both ends go down. I'm going to do a table of values. I'm going to use negative 2, negative 1. I'm going to have to use a fraction. So I'm going to use 1/2. So first plug in negative 2, positive 4, but it's negative in front, negative 3, and positive 1. Altogether, that answer is 12. Plug in negative 1 and see what answer you get. And you get positive 4. Which one's going to be your turning point? The one that gives you 12 or one that gives you the answer 4? So at negative 2, it goes up to 12. And then at negative 1, it goes up to 4. So I have this piece. I know at 0 it touches. I have to plug in a fraction between 0 and 1 to find the turning point. Now, 1/2 times plus 3 is 3.5, but I'm going to change 3.5 to an improper fraction, then multiply. This gives me a positive answer. 7 on top and 16 on the bottom. So almost a half. So at 1/2, the answer is like a half. Where is this function increasing and where is it decreasing? So it's increasing from negative infinity to negative 2. It's increasing from 0 to 1/2. Where is it decreasing? From negative 2 to 0 and from 1/2 to infinity. These 2 points are maximums, and this point at 0, 0 is a minimum. When you're ready, number 11, no graphing now. All right. Are you ready for number 11? In number 11, what are you asked to find? All what? Real solutions. Does that mean there'll be any complex solutions? Anything with I in them? No. So even if there is a complex solution, you're not going to write it down. So the next question is, how do I solve this? And the question should be, answer should be, can you factor it? So if I factor out an x squared, I'm left with x plus 6. If I factor out, what's the only thing they have in common? A 2. So if I factor out like a negative 2 even, I have 7x minus 8. Can you factor this by grouping? They don't match. So if you can't factor it, what must you do to be able to solve this equation? No, can't use the quadratic formula because it's not a quadratic equation. So instead you have to do the rational zero theorem. And the rational zero theorem creates a list. Is the leading number 1, then you can go to the last number. What are all the numbers that go into 16 evenly? 1, 2, 4, 8, and 16, both positive and negative. Next, how do I test the list? Is using synthetic division. You're looking for the one number that gives you a remainder of 0. Negative 8 works. And there's no real shortcut to actually trying and then failing until trying and working. So I'm going to go with negative 8 because I believe you. So 1, you drop down. Negative 8 times 1 is negative 8. A negative times a negative is positive 16, and add. And then negative 16 gives you a remainder of 0. So what's one solution to this equation? I already know one answer is what? Negative 8. What's left over is x squared minus 2x plus 2. Is that factorable, what's left over? No. So what are the two options you have here? Either complete the square or the quadratic formula. Which is the better option here? Complete the square because it's simple with an even number. Now, when I complete the square, I'm going to subtract 2 to the other side. And then on the side, I'm going to take what b equals, which is negative 2. And I'm going to do two things. I'm going to divide it by 2 and square it. That gives me the answer positive 1. So I'm going to add 1 to both sides. When I factor this, it's going to end soon. What two numbers multiply to 1 and add to negative 2? Negative 1 and negative 1. And negative 2 plus 1 is negative 1. What happens when I take the square root here to try to solve it? These solutions are going to be what? So what's the only real solution to this equation? Negative 8. If you had to go further, then you would go, the square root of negative 1 is I, positive or negative, and then the last step would be to add 1, right? So the last two solutions are complex, but they only ask for the real solutions. So that answer would just be negative 8. When you're ready, turn the page. Number 13. Number 13 says, find k such that this function has a factor at x plus 1. find k so that it has a factor at x plus 1. If there's a factor at x plus 1, that means when you plug in the 0, so what's the 0 of x plus 1? When I plug in negative 1, what would the answer be if it's a factor? And the answer is it would be 0. So, wherever there's an x, we're going to plug in negative 1. K is what I'm solving for. And I'm going to make it equal to 0. So what makes that a factor is if you plug in the 0 and the answer is 0. So what's the 0 of x plus 1? Negative 1. So wherever there's an x, plug in negative 1 and make it equal to 0 and now solve it. So negative 1 to the 4th is just positive 1. Negative 1 cubed makes it negative k. And then we just have a plus 2. And now I just need to solve for k and I have my answer. So I know that 1 plus 2 is 3. And if I add k to the other side, what would k have to equal for x plus 1 to be a factor? And the answer is k would have to equal 3. There is a high probability that question will be on your final exam, just in case you think you want to ignore it. And you already know that the questions we're doing you're going to see on your final exam, right? You just don't know which ones. Darn it. Number 15. Do you want me to go over again why I plugged in negative 1? If x plus 1 is a factor, what's the 0 of that factor? And if you plug it in, the answer has to be 0 for it to be at 0. So you plug in negative 1, make it equal to 0, and solve for k. All right, number 15. All right, number 15. It says use the remainder theorem to evaluate a function. So, I taught you a different way to evaluate. The old way to evaluate is to plug in and do please excuse my dear Aunt Sally, right? You plug in and no matter how big the numbers get, you just do the math. What's the new way to evaluate? Is to do synthetic division. So in number 15, if I want to know what f at 6 equals, I take 6 and I divide it into, how many x cubes do I have? 1. X squares. X's. Do you have to be careful about 0? If there is a missing power, right? And then, what I'm looking for is simply the remainder. So what is the new way to evaluate? Is to divide, and the remainder is your answer. This is what I'm looking for. F at 6 equals 312. What did you use to evaluate? You used what's called the remainder theorem. That if you find the remainder, that's the answer. And believe it or not, that's easier sometimes than having to multiply it all out. Number 17. What does number 17 ask for you to do? Do I have to find the zeros? No, I just have to list them, right? Now, I want you to look. Is the leading coefficient 1 or is it a different number? So what are the numbers that go into 3 evenly? Positive and negative 1 and positive and negative 3. What's the constant at the end? What are the two numbers that go into that evenly? And now it's all combinations of the last over the first. So, can you take the first number here? What's 1 over 1? And 1 over 3. And then we do it again for 2. What's 2 over 1? And what's 2 over 3? And that is the complete list. The order doesn't matter. That is the complete list of possible rational zeros. If this function has a rational zero, it's one of those. Okay. Number 19. Now, what's different about number 19 compared to what we did last page is I have to find both real and complex. The first thing you should think is it factorable? Do they have a common factor to pull out? And the answer is no. So next, what do? Is I need to create a list. So the leading number is 1, so I just have to look at the last number. What's all the numbers that go into 39 evenly? 1, 3, 13, and then I need to test the list out by doing synthetic. I have 1x cubed, negative 3x squared, negative 5x, and 39. Positive 1 does not work because it doesn't add up to 0. So, you have to find the number that gives you the remainder 0. So, negative 3. Now what's left over is x squared subtract 6x plus 13. It is not factorable. I'm going to solve this by completing the square. So I'm going to subtract 13. B is negative 6. Divided by 2 and square it. So I'm going to add 9 to both sides. When you factor the left, it's negative 3 squared. And on the right side is negative 4. Next, take the square root of both sides. Know that when you solve a quadratic, the answer could be positive or negative. What is the square root of negative 4? 2i. And then what's the last step? Add 3. So what are the zeros of this function? So if I listed the zeros, it would be negative 3 and 3 plus or minus 2i. When you're ready, turn the page. Every question I'm not doing are the most important questions for you to do. And I'll have an answer key for you, so you can check to know if you did it right. All right, 21. Do you know what we call these questions? These are rationals. Can you see that? What does the dot tell you to do? The dot says to multiply. So, in order to multiply, the first step is to factor. So, each numerator, each denominator, factor what you can. So, 5x subtract 5. Can you factor it? 8x subtract 8. Can you factor it? Once it's factored, we can then cross out. Is there a common factor on top and bottom that we can cross out? So x minus 1. The x makes the x squared just x, and the 4 makes the 8 2. So what's left that I did not cross out? A 5 and x, and on the bottom, just 2. Look at number 23. At number 23, do you know how to add fractions? What's the rule to adding fractions? The denominators need to be the... So how do I make them the same? Well, the first fraction needs x minus 2. And the second one just needs x. And now are the denominators the same? Once the denominators are the same, what do? The denominator stays the same. And I combine like terms on top. 4x and 6x makes 10x. And 4 times negative 2 is negative 8. Done. Just like that. Factoring out a 2 on top doesn't make anything easier or simplify anything. So you can leave it just like that. Number 25. Number 25, the rule is the denominators have to be the same. So what I'm going to do is, first I'm going to factor it. Both are a difference of squares, but order matters here. So one is going to be x plus 8x minus 8, and the other is 8 plus x and 8 minus x. So the order matters. Do you know that 8 plus x and x plus 8 are the same? So what's missing here is 8 minus x, top and bottom. What's missing here is an x minus 8, top and bottom. Last step is to combine like terms. So I have 8x minus 8x. That would be nothing, right? 8x minus 8x. That's done. I have negative x squared. I'm going to write that down. So x times 8 is 8x. Negative 8 times x is negative 8x. They cross out. I have negative x squared. Negative times a negative makes it plus 64. If I factor this, negative x squared plus 64 is a difference of squares. And then a bunch of stuff crosses out. And I'm left with 1 over x minus 8. This on top is the same as 64 minus x squared. So if I multiplied by negative 1, then the bottoms would match. And then it would be x plus 8. And then you'd factor out the bottom. Is that what you're saying? And then you get the same answer? Perfect. Number 27. Perfect. I'm glad you saw that. Tell me.
Why did you put the 8 minus x on top and bottom and x minus 8?
So this way, why did I put 8 minus x on top?
Yeah, and bottom.
And bottom. Because I need to make the denominators the same. So when I look at the denominators, both of them, the first one is missing 8 minus x. And the other one has it. For the bottoms to match, whatever's missing, I need to multiply top and bottom by what's missing. All right, we're going to do just a couple more. Can't do them all today. I got to save something for tomorrow. So, 27. Do you know how to do long division? Now, I'm going to remind you about long division. It's the first term divided by the first term. So 5 divided by 5. So you can do it in your head or you can write it down. But it's the first term, the leading term divided by the leading term. The power divided by the power. That gives me 1x squared. And then you distribute. So you multiply it. X squared times 5x. X squared times negative 2. And then what do is you subtract. Be careful, when you subtract a negative, you're adding. So negative 7 plus 2. Then bring down the next term. Again, divide. Negative 5 divided by 5 gives me negative 1x. Distribute. Subtract. So a negative times a negative is positive 2x. Subtract and you get 5x. Bring down the last term. 5 divided by 5 just leaves you with 1. And that's 5x minus 2. Subtract. Now, the answer, the remainder is negative 8 plus 2. But what do I do with that 6? Is I write it as a fraction at the end. We're going to do that one more time. And then this will be our last one for this video. So number 29. Number 29. By the way, for 29, it doesn't tell me what to do. Can I use synthetic division for 29? Yes. Could I use synthetic division for this? No. Only a simple linear. So, am I going to do long division? No. What's the 0 of this? What are you going to have to be careful about? 2. Negative 4. 0. Why am I having a 0 right there? Is it missing a term? So if it's missing a term, it needs a 0 or else it won't work. Now the answer's here. How do I write down this answer? So, what's the degree of my dividend? It's 4. My quotient, my answer, is going to be 1 degree less. So how many x cubes do I have? 2. How many x squares? 2. How many x's? The constant. And then what do I do with the remainder? Is I write it as a fraction over x minus 3. All right, so there's work on polynomials and some rationals. Mr. GMath, over.